Welcome to another podcast. In this episode, we're going to be taking a look at how to work with factorials. This is an important skill for you to be able to master when working with permutations and combinations especially, but it's more of a broader, general skill that'll help us through the rest of the counting and the probability sections. Let's start off by describing what a factorial is and what it does. So just to start with, if I write n factorial down, then you should think of that as being n times n minus 1 times n minus 2, and it keeps multiplying down until you get all the way down to 1. So for example, 5 factorial would be 5 times 4 times 3 times 2 times 1, which happens to be 120. Now, the basic idea here is that the factorial represents something that can be counted. The fancy math term for that is combinatorics. It represents something in combinatorics. And that is, n factorial represents the number of ways to rearrange n items. So for example, let's suppose that I had 8 books and I wanted to know how many ways to sort them on a shelf. So you've got 8 books, let's say in the library, and you want to line them up in a row on a shelf. How many ways are there to do that? Well, the simple answer to that is that there are 8 factorial ways. Let's see, 8 factorial, that's a big number. Let's go ahead and bring in a calculator and we'll deal with that. So 8 factorial is 40,320. So there are 40,320 ways to arrange the books on a shelf. Now, the other reason that this is important is because we're going to start looking at permutation and combination formulas. So let's start with the permutation formula first. Remember, permutations count arrangements. And the way to think of it is, with the permutation, we use the notation P and R. The P stands for permutation. The N stands for the total number of objects. And the R stands for the objects ordered. So the number of objects that are ordered. So for example, P 5 3 literally means you have 5 objects. You're going to choose 3 and then you're going to order them. So P53 is based on a factorial formula. The formula for P53 is that you take everything and order it. So you take all 5 objects, all 5 factorial objects, and then what do? Well, you take 5 minus 3, which is 2 factorial. You take the 2 objects you don't care about and you throw those away. That's why you divide out by them. So the idea is you want to choose 3, so instead the formula says take all 5, order them, and then cut off the last 2, and that'll leave you with the 3 that you want. So 5 factorial divided by 2 factorial would be the way to handle something like that. So you see here how factorials naturally arise when you look at permutations. That means we need to be able to algebraically handle something like this. And so I want to do a little bit of just some computational work here with you to do some simplifying. So let's say I asked you to find 6 factorial over 4 factorial. Well, the top is 6 times 5 times 4 times 3 times 2 times 1. And so you see in the bottom you've got 4 factorial of 4 times 3 times 2 times 1. So the obvious thing to see here at this point is that you're going to get some cancellations to occur. And the cancellations that occur are up to the difference between the two. It's going to leave 2 terms. So you see the difference between 6 and 4 is 2. That's why it left these 2 terms. And so 6 factorial divided by 4 factorial is 30. Because of the way that this mimics the formula down here, you can also think of this as being P6, and then how many objects are chosen in this case? Well, the 4 is on the bottom because you're throwing 4 away. If you're throwing 4 away, then you're keeping 2. So you can see sort of the relationship that that has to the permutation formula. Let's do a little more complicated one. Let's do 8 factorial over 3 factorial, 2 factorial. So we know what 8 factorial in the top looks like, and we know what 3 factorial in the bottom looks like. If we take this 3 factorial and divide out the things from the 8 factorial, what will that leave? That'll leave 8, 7, 6, 5, and then 4. And then this 3, 2, 1, those are all taken care of here. And so you get 2 times 1 left in the bottom. And here you can just take term for term. So the 2 will cancel with the 4, leaving a 2. So let's see, if we multiply everything that's left here, that looks like, let's see here, $3,360. I believe that's correct. Let's check it. So I want to do 8 factorial divided by 3 factorial, 2 factorial. And that is indeed 3360. So that's good. Alright, why do I want to look at ones like this? Well, the simple answer to that is the other side of this permutations coin is something called a combination. Combinations, rather than counting arrangements, count choices. And really what they do is they count subsets. We'll talk more about subsets in class, but they count the number of subsets. The notation is similar. We use C and R, where the C stands for combination. The N and the R in this formula are exactly the same as the N and the R in the permutation formula. And the formula itself is N factorial over R factorial N minus R factorial. Now, if you compare that with the permutation formula here, you can see the permutation formula was N factorial over N minus R factorial. And so when comparing these two, so comparing this formula with this one, the difference that we see is the R itself. So this term right here, this R factorial term, that is the major difference between the two formulas. So what is that R factorial term for? Well, remember the N minus R, this is the leftovers, right? So we're throwing away the leftovers that we don't want to order, like we did in the permutation formula. But the R factorial is we are not arranging, we're simply choosing. So dividing out by the R factorial is throwing away all the different ways that we could have arranged the R items. So taking, for example, the book example that we looked at, rather than try to order all 8 books, all I'm interested in is picking 8 books, and that's a lot simpler problem. So in general, combinations are going to be smaller than permutations, always. I guess the one exception is when you're choosing one thing. So if you're permuting one thing or choosing one thing, then they're going to be the same. But other than that, they're going to be smaller than permutations. All right, I just wanted to take a look at all the interesting uses of the factorial to help us count using both permutations and combinations. You're going to need to be able to do the algebra and be familiar with these calculations. Although our calculator will handle it, it's always a good idea to be able to fall back on some basic skills that you can use pencil and paper to be able to come up with these answers yourself. All right, thank you for watching.